What's up, baby bio penguins? Today, 2015, number 5 on phototropism. Phototropism in plants, the response in which a plant shoot grows towards a light source. The results of 5 different experimental treatments from classic investigations of phototropism are shown above. Here I see in group 1 that my tip 1. What's up, baby bio penguins? Today, 2015, number 5 on phototropism. Phototropism in plants, the response in which a plant shoot grows towards a light source. The results of 5 different experimental treatments from classic investigations of phototropism are shown above. Here I see in group 1 that the tip is unaltered and that it grows toward the light. Here I see in group 2 that the tip has been removed and it grows straight up. In group 3, the tip is covered by an opaque cap, which means light cannot get to it, and it also grows straight up. In group 4, that tip has been separated by a permeable barrier, so it's cut off and then reattached with a permeable barrier, and it grows towards that light. Versus in 5, we see that it also is separated, but I have an impermeable barrier. So part A asks us to give support for the claim that cells located in the tip of the plant shoot detect the light by comparing the results from treatment group 1 with the results from groups 2 and 3. So if I look at 1, I can see that my tip has been unaltered, and I see that it grows towards that light. Versus when that tip has been removed, it grows straight up, which tells me that the tip must be responsible for detecting that light, because when I have the absence of the tip, the plant is going to grow straight up. So if the tip is removed, the plant no longer bends toward the light. If I look in between, again, group 1 that grows toward the light and group 3 that does not grow toward the light, I can see now my difference is that I have an opaque cap. Okay, so though the tip is present, it's covered up and it's unable to detect that light. And so since that tip doesn't detect the light, it grows straight up. And so that tells me again that the cells in the tip of the plant are responsible for detecting that light. So in treatment 3, the cap blocks the light to the tip and the plant no longer bends toward the light. Student said the plant with the unaltered tip grows towards the light, but the plant with the tip removed did not, showing that only the tip and not the entire stem will respond to the light and grow towards it. Even when the tip cells are not removed completely and the tip is covered, so it is not exposed to light, the plant does not grow toward the light. This shows that the tip itself must be exposed to light in order for the plant to grow towards it. Part B says in treatment groups 4 and 5, the tips of the plants are removed and placed back onto the shoot on either a permeable or impermeable barrier. Using results from treatment groups 4 and 5 describe 2 additional characteristics of the phototropism response. So I see here that I have a permeable barrier and it does grow toward the light. Versus here, I have an impermeable barrier. Now, we've already established that there must be something in the tip that allows for the plant to grow. I can also see that there's like more of a bending, okay? And so that tells me that there must be some chemical that's made in my tip that is then going to diffuse lower down onto my plant to allow the plant to grow towards that light. Because when I have a permeable barrier, that material that's made is going to be able to diffuse. Versus here, although it's being made, it cannot diffuse to the rest of the plant, and thus it does not grow toward the light. So the tip produces a substance, a signal, a hormone, and if you were specific, you would say auxin. Not really required for you to know that hormone, but there you go. In response to light, causing the plants to bend. Or then you also talk about the substance must be able to diffuse from the tip to the rest of the plant in order for that plant to bend. Students said the tip sends the signal to the rest of the plant to grow toward the light. In group 4, the signal can be passed through the barrier, so the plant grows towards the light. In group 5, the tip is unable to pass the signal to the rest of the plant, so it does not grow towards the light. This shows that growth of the plant in response to light does not just occur at the tip, but occurs the entire stem. Hope that was helpful. Remember, AP5 was just a test by all.